Hi, I'm Terry Monville, Technical Advisor with WEST SYSTEM Epoxy. Today we're going to take a look at one of the two engine hatches out of a 1978 Formula 255. They're pretty well beaten up, soft in the middle from being walked on, chips around the edges. We can see that the flex in this hatch has been ongoing. The previous owners at some point added in a 1x3 and fiberglassed over it, trying to stiffen the hatch up. But because we're limited on room, you can see here, the flame rester on top of the motor is touching the bottom of the hatch. So we can't make it any thicker, which would normally be the first thing to do to make it stiffer. We have to redesign it and use a little bit better materials to stiffen it up. So seeing how we have two of these hatches to build, and they're both in tough shape, it's gonna be easier to build a separate mold versus trying to pull a mold off of here. Again, it's not in the shape we want, lots of chips and nicks around the edges. And we don't have any non-skid in here that we're concerned about repeating or to match the rest of the cockpit. The one thing we do have is a recess for the lifting handle. So the lifting handle fits in nice and looks good. There's a couple of different ways to do this depending on the outcome you want. The simplest is not to worry about it until after the hatch is built and just router in an area for the recess, the way we're gonna end up doing it. The next simple way would be just putting a little piece of plastic into the new mold to get your offset there and then router it in. Or the third way is actually pull a mold off of this section. We'll repair these screw holes, clean this up, wax it, and pop out a little plug that will glue into the new mold. We've decided not to use that lift handle, and we're going to go with more modern lockdown latches on this particular hatch. This is a very simple rectangle, and a couple of things we have to really pay attention to. The critical measurement is the thickness of this flange here, or this flat area. It's 210 thousandths we measured, or 7/32. This is critical because this sits onto a lip inside the opening on the boat and determines how the top of the hatch sets flush with the rest of the cockpit. So we want to make sure we keep this thickness about the same. This is determined by the amount of glass that's on the top and on the inside of over top of the plywood in here. We also know that this is 3/4 plywood, and we can't go any thicker than that because we're already hitting the flame arrestor, as we recall from earlier. Seeing how we want the top to be flat, and this is simple shape, we're going to use a sheet of melamine board, and we're going to cut it in half and use half for the top surface of the hatch, and then use strips off the rest to build a flange around the outside. So let's take a look at that. Now that we've got it placed on a melamine board, that takes care of the top. It'll be nice and flat because we've got something flat to go against. The next thing to take into consideration is this lip on this edge of the hatch. We'll need to build a flange to go around the edge of that to build up. So what we've done is cut strips with the rest of the melamine board to create this little shelf. This will take up this part here of the flange, and this will be a flange that we can put the vacuum bag down to and roll the edge of the fiberglass up on. So that will end up sitting around the edge like so. We're going to need to build enough of that to go all the way around. We're going to start the next step by just drawing around the hatch so we have a good shape of it. We have to keep in consideration is that these black lines are the very outside of the hatch. So we know that the inside of this flange has to line up and basically cover that line. So that'll be a good lineup mark. Also, to get the part out of the mold when we're done, because it's going to be a square, you have to put in what's called a relief, and that's a 3 to 5 degree angle here. So I'll exaggerate it. It's going to be tilted out like this so that the part can lift out of the mold. So we'll cut that 3 to 5 degree angle on the very bottom of here when we build these parts. So we end up cutting the strips 7/8 tall because we want 3/4 left over, and I cut a 3 degree angle, so that will set up on here like so. And then on the flange, we beveled the back side of the strip and the flange on 45s so that they'll meet up, and I'll glue these together. This will give us enough relief to get the part out of the mold, and then also have an area to put the vacuum bag down on. We'll make up 4 strips all the way around and cut them to length. Again, anytime you're using epoxy, you should have safety glasses on and wear gloves. It's best to keep it off of your skin and out of your eyes. We'll take the time to bond together the strips that go around the outside that we cut earlier. I'll be gluing these upside down because I want the this surface that faces into the mold and the top to make a nice 90-degree corner, which we'll router later to smooth out, but because they're a different height, you have to do them upside down. We're gonna be using our 610 thickened epoxy in a caulking tube to bond them together. It makes a great structural adhesive. Also, I gotta make sure I get contact all the way along because we plan on vacuum bagging the part in the mold. The 610 is easy to use. It does use a standard caulking gun. This one actually has a little bit of mechanical advantage. It's not required, but it makes it a little easier on the hands, especially if you're doing a lot of caulking. When you first start, what you wanna do is squeeze out a little, make sure they're coming out evenly. This one's pretty good. Wipe it clean, and then add the mixing tip. When it comes out mixed together, it'll be a nice straw looking color, just a light yellow. If it was only hardener, it'd be the bright yellow, or resin only be very clear. This is one good way to know that you don't have a problem and that it's being mixed together real well. We'll just lay a nice bead all the way along. We'll just use a weight to hold to one side. Push it together good with your hands. You gotta be careful not to press too much. Is it pressing this, trying to clamp it together? Because of the 45s, it wants to slide up. So make sure it's together good and down. I'll put that one there. And we'll put this one here just to hold that, which then will hold our next one. Then you can clean up any squeeze out just to make sure it's not sticking down too far. And then we'll move on to our next two. So our 610 is cured on our pieces that we cut yesterday, glued up. I added a 1/4-inch radius on the top edge of it so that fabric can roll over nicely and not get any air voids. So that I don't accidentally scratch the mold surface that we want a nice finish on, I'm gonna tape it off before I start sanding. And just tape it off the black lines I put there yesterday. They're a good guideline. And then just take a little 80 grit by hand and scuff up the area. Just clear the dust away. All right, now we're gonna take and line up our edge pieces. So that's a kind of a general set on these. If you notice, they are a little wiggly because of the angle on the bottom. So you can use a lot of different things for a wedge and back. I happen to have a lot of squeegees around, and it seems to be about the right height to kind of flatten it out so you don't get the rock. And then add a weight on top to make sure they stay in place. And follow the same procedure all the way around. Now that we've got them set in a general positioning, we'll do the final location of them. For this, you want to make sure your corners are square. You can use a basic combination square, or if you want a larger square, but this will work fine for this project. And now that we've got it square and generally in position, we're going to double check our measurements. We're very close to the line, but we want to make sure we're exactly right, matching up to the hatch itself. So on the hatch length, we're at 43 5/8. So we'll check it here. Okay. Once we have that, we'll double check our squareness down here. And we'll also check the width. Just 33 7/8. So pretty darn close there. Also got to take in the consideration that when we're measuring the outside of that hatch, we'll slowly remove one piece at a time and apply 610 underneath it to hold it in place and fillet the corners. We put a new nozzle on our 610 from yesterday, and we'll pump off a little into a cup. Just make sure we've bled the tip. And we'll just lay a nice simple bead along the bottom. Again, the black line gives us a good indication of where the edge of the board will be. And you'll want to put a little 610 where the boards join, because we want to glue the boards together into a solid frame, so there's no little air leaks through the corners. So now that they're glued in place, we're going to follow back up again and check corners for square and for our measurements. This is going to be your last chance to get it right, so it's worth taking your time. There's a couple of spots like over here where it seems to be up a little. I'm going to grab a couple extra weights and set them around, and then let this cure out for a few hours before we go put the fillets in the corners, so that way we're not moving and bumping it. The 610 has cured and holding the rails securely in place. We're going to remove the weights and get ready for the next step. What we need to do is in these corners, put in a little fillet to match these radiuses. And then we got a little bit fatter radius in the corners themselves coming up. So for reproducing the radiuses in the corners, we're going to use this fondant tool. It has balls on the ends, so it makes a great fillet, and it stays consistent because no matter which way you hold it. And when you get down into the corners where you're doing the different shapes and corners come together, it remains the same. With a radius like on a mixing stick, it depends on what angle you hold it at, so it's going to change. This will keep it consistent. So for around the bottom perimeter, we're going to use the small end of the radius. And for the corners, which is going to duplicate this corner coming up, we're going to use a larger end because this is a larger radius and want to try to match it with what's on the boat. Now for making the fillets, you can use the 105 system, 105 with one of the hardeners mixed up and the thickening agent. To make it easy, I like using the 610 again. It stays in place and it's very easy to apply. It's already in a caulking tube, and you can put down this nice little bead. And then take your fondant tool and got a little too much in there. And then on each side of that radius is a little bit that was extra. You can just scrape that off with your mixing stick carefully, and we'll move on to our next one. So the other day we pulled a mold off the recess for the lift handle, and this would be the time to place this into the mold if we're going to use this. You'd sand the back of it, locate the position off the other hatch, and place it and glue it in place so it's ready to go when we wax the mold up. We've decided not to use that lift handle, and we're going to go with more modern lockdown latches on this particular hatch. So we let the 610 fillets cure overnight, and next step is to wax the mold. But before we do, we want to check a couple of things. One, that we cleaned up our 610 well. You want to feel along the edges here. Any little bumps sticking out will lock the part into the mold. So right here I can feel just a little piece of 610 I missed on the cleanup. So I'm just going to scrape it off with a razor blade. And that will keep it nice and clean. Also, if there's any rough spots you don't like, now would be the time to sand it and smooth everything out. Whatever's the mold surface is like, it's going to be duplicated onto the part. Even the little texture that's in here on the melting board is going to transfer over to the part. The other thing you want to make sure of is that you get all the dust and dirt out of it. You don't want to wax in any of the dirt. That again will show, and it could also create a sticky spot. And what I mean sticky is so that the part actually sticks to the mold, and we wouldn't want that to happen. Now the other thing we have to address at this point is this radius. If this was going to be in the finished part, I would have sealed it with epoxy. Again, because I want a nice smooth finish coming off of the part. But this is actually going to get cut away. So what I'm just going to do is just make sure it's waxed up really well. Any little splits in it where it didn't fit together well or the 610 didn't fill in, I'm going to make sure I'm going to pack it with wax so that the part doesn't stick. After it's been removed, that radius area will be cut away from the hatch. And putting wax on molds, much like waxing a car, nice little circles, making sure you're overlapping and getting all the areas. When we come back to do the next coat, we'll actually start in a different location to make sure we're not making the same mistake in the same area each time. Wax right up on the flange, that way if anything gets up there it won't stick. And just like waxing your car or your boat, you let it haze up and then you buff it off. Now that we've got all buffed off and cleaned up, we'll wait at least a half an hour in between coats of wax, and we'll do a minimum of 3 coats. Now that we've got our 3 coats of wax on, now the next step is to put on a thickened coat of epoxy. The thickened coat of epoxies will go on the surface to help prevent any air voids and imperfections of just if you were to lay on just fabric without it. This will make a nicer finish for when you go to paint the other side of it. The reason we do a thickened coat rather than just a neat coat of epoxy, unthickened, is it's too watery and too runny, and on the wax surface the tension will actually make it fisheye and won't lay level. To help prevent the epoxy from creeping back like this on the wax surface, what we've learned from experience is 3% of 404 mixed in and 3% of 406 by weight mixed in makes a nice viscosity for spreading, and then also it won't creep back. So the first thing we'll do is we'll put an empty cup on the scale and zero it out, and then we can weigh our epoxy. In this case we have 142 grams. So we only need about 4¼ grams of 404 and 406. So we zero and add our 4 grams. And we do this by weight because it's hard to tell by volume, because the fillers can be a little more compact or not in each. And as you can see, a little bit of 404, the same amount of 404 and the 406 is not close to the same volume. Mix your fillers in well. If you have any clumps in there, kind of bust them up with the stick. It ends up being about a thick ketchup consistency. And as you can see, with the added filler into it in this area compared without, how well it's holding together and not creating openings. Once you get the epoxy on the surface, you can do nice long strokes to level it out so it's nice and smooth and even coating all the way across the mold. As you're spreading it out, it's important to get it good into the corners. Kind of tab it in there and leave even a little extra. Remember when we were looking at the original hatch, I had a whole bunch of air voids here. This will help prevent them. And we'll take a look at tomorrow when we get ready to lay the fabric in, putting a little more filler in the corners to help reinforce them. So the idea is to work in multiple directions, making sure you get all the areas covered. When you put the brush down, you want to be very gentle and move it along. You don't want to stick it because you'll create a hole in the surface. And by doing this, we'll be able to get a nice even coverage all the way across. And what we're looking for is about what they consider 20 mils. What that works out to being is a little less than a 64th of an inch. It's very thin, but you can see that there's some coverage there. So on the second half of the hatch, we're going to add in some 501 pigment to turn it white. I've already done that over at the workbench. And the reason for this, it doesn't add any UV value to it, but it does make it a solid color and help cover up the color of the cloth behind it. And it helps act as a primer coat for when you get ready to paint and prime, or for gel coating over top of it, it hides better. As you noticed, I've been using the same cup all along. I just make sure that I get all the epoxy out each time, and that way I'm getting a fresh mix and I don't have any cured epoxy in the cup when I start. The little bit of residue is not going to hurt anything. So when we add the pigment in, it doesn't take a considerable amount. You don't want to exceed 3% by volume, but you know that will be more than enough to do it. So the first layer into the mold is cured overnight. This will make it nice and stable. This will keep the air voids off the surface. The surface coat provides a couple of features. One, it helps prevent any air voids and imperfections in the surface when you take the part out of the mold. Also, it helps prevent print through, and that's one reason we let it cure. Print through is when the fiberglass or the core telegraphs through the top coat, in this case surface coat, or on a typical older powerboat gel coat, and you'll be able to see the pattern. Our next step after this cures is we need to remove the amine blush. Amine blush is like a waxy film that cures on the surface. You might not even notice it, but it's there, and it removes simply with water and a scrub pad. So that's what we'll do now. Now you could avoid the step of scrubbing this down by not letting the epoxy fully cure and starting your lamination while this firmed up but wasn't all the way cured, and you'd still get a chemical bond that way, but you have a higher risk of the print through of that situation. And then for cleanup, nice white clean paper towels. So the blush is water soluble, so that's the reason we use water as solvent when it cut it. But if you just washed it with water and let the water dry, the blush would form back on the surface again. The water lifts it up, dissolves it, and then you wipe it away with clean paper towels. And you can see that this side looks dull, where this side is still shiny. And that's one way to indicate that you've done a good job. And if you're in doubt of how well you've cleaned it, it's always good to just follow back with a little bit of fresh clean water and give it a wipe to pick up any stray contaminants. I've noticed while I was scrubbing it down that I got a couple bumps and lumps that are a little more aggressive than what I'd like, so I'm just going to hit a little bit of 80 grit sandpaper and knock those down. It doesn't take a lot, but it'll help the fabric lay in nicer. So before we go any further, the next step is going to be, I'd like to tape off the edge. As we talked about earlier, we're going to vacuum bag this part in. And there's a couple different ways you can go about this. Some people put the tacky tape or vacuum sealant tape down first and then tape over it. I just tape the area off so we don't do any damage to it. And the reason we're taping it off is because if you get any epoxy on this flange area where you're going to put the vacuum sealant tape, it's not going to stick at all and you're going to have a bad leak. So this is just making sure we don't make any mistakes that will hurt us. So the first layer in is going to be this 8-ounce carbon. The reason we do a lightweight to start with is it'll tuck and fit into corners better first, and it also helps with print through. Again, so that it doesn't telegraph through and see the weave of the fabric. Heavier the weave, the more likely that is to happen. The 8 ounce will be the first one into the mold to help prevent with print through and tuck into the corners well. And then we're going to do 3 layers of biaxial 17 ounce carbon, balsa core instead of the plywood, but we're keeping the 3/4 thickness, and then 3 layers of 17 ounce biaxial on top of that of carbon. And that should give us a hatch that weighs about half the weight the old ones did and actually be stiffer. So I'm going to take this out for now and we'll grab the balsa core. As we put the balsa in here, you'll see I'm putting in different blocks and sizes. One sheet of balsa is not large enough to go in, and also this is from a cutoff from another project. So we're just going to fill in the little excess areas with other chunks of balsa. As you can see, it's on a scrim, so you can cut and fit it pretty easily. We use these witness marks so that we line up, so all the pieces that we have, we know exactly where they go, because you don't want to be stumbling around and trying to figure out where they go during the layup when the glue's wet and curing. So now that we've got it assembled in the mold and start dry fitting it, we're going to take some measurements off of the old mold and just kind of make sure that it gives us enough room all the way around so that it will fit back into the boat. If we went too far out, the balsa would hit the edge of the boat where it actually rests on this flange area and throw it off, obviously, when it fit down into the compartment correctly. We have our plywood in this area where the locks will go for reinforcement. That way we don't have a chance of crushing the balsa when we're putting it in because it does clamp in place. Then also, you notice down here we cut the 45s just like the old hatch. In the boat, this is where the drains are for the water trough that's around each hatch. Now that we're ready to start the lamination, the first thing we're going to do is put a fillet all the way around in the corners to help the layers of carbon flow over easier. 90-degree corners are very hard to get any type of fabric to shape over. Again, that's why we radius the top. I'm going to use the 105 and 206 with the 406 filler to thicken it. You want to make sure you get it packed in good and that you don't create any air voids behind it. That's one of the reasons for doing it, is so we don't get air voids. Now that we've got the fillet put in all the way around, I'm going to mix up another batch and start coating out the main part of the mold. On the first layer down, I do like to put a little bit of 406 into it, just to maybe a catch-up consistency. That will help fill any brush marks or imperfections that are left in the surface. And again, it's very pourable. Like I said, I describe it as cheap ketchup. And just put a thin layer throughout the whole surface. This will also help wet out the first layer of carbon as it goes into the mold. So as we set the first piece of carbon, I'm going to set the far side so it kind of lines up where I want it, so I only have to trim one end of it at a time. And even though that we're going to put a vacuum bag on this, you still have to do a good job of basic lamination, get all the wrinkles and air voids out from underneath each layer. The vacuum bag just helps with getting the resin content right and some compaction. In the corners, if it doesn't lay down nicely, you can actually put a little cut in there, or dart it as we call it, and fold it over so it fits nicely. This layer is only going to take about 8 to 10 ounces to wet out. The 17 ounce will take about 20 ounces to wet out because it's just over a yard of fabric. And to do this quickly, we got help from a co-worker. So we're gonna weigh it out to mix up larger batches. Otherwise we'd be pumping quite a bit. It'd be like 25 pumps of each. And when using 206, the mix ratio by weight is 5.3 to 1. That's 5.3 resins to 1 hardener. I'm just using a brush to get the edges worked in nicely and use up some of the excess resin. So when you prep your fabric, folding it or rolling it up nicely so you can set it in and keep it straight as it goes in really helps out. One of the tricks of working with epoxy is when it's in a large mass, it actually cures faster as it heats up from exotherm. So getting it spread out will extend your working time. One of the things to consider doing a larger project, especially if it extends over a half an hour, is changing out your gloves. Even good quality disposable gloves can permeate through with the epoxy after time and saturation. It also helps keep the work area cleaner. So the next step of the project is to put the core in place. But before we place it, a couple of things to pay attention to. The outer edge, I actually sanded down a little radius on there so the carbon fiber can roll over easier, and we'll also put a fillet on after it's placed in location. The other thing we're going to do is between each square of balsa is actually wet it out with epoxy. So we'll bend it, open it up, do a quick brush on each one. By wetting out each individual cube, we actually create a waterproof cell. So if there was a puncture in it, the deck someplace, say someone added a fastener for a hold down handle or something, and moisture got in, it wouldn't be able to travel outside that single cube. It'll also stiffen it up some without adding a tremendous amount of weight. And then we also wet out both sides completely so that it doesn't pull resin out of the fabric. Now this is a flat panel. We could actually put this in either way, but the balsa's on a scrim in each little block cut so that it could go around a radius if you're doing a deck or a hatch that had more shape to it. But just out of practice, we always put scrim side down. So I was working on the last layer of fabric going in. Don was in the background getting all the balsa ready for us and did a great job of it, nice and wet. So we'll start setting it in place and getting our measurements so we're kind of have it centered nicely. Again, just like the rest of the core, the blocks get completely saturated also. If we weren't going to vacuum bag this core in, I would have normally put down a thin layer of epoxy with 406 in it to bed the core, and that makes sure we get good contact between the skin and the core. And then on top, I generally put down another light layer of maybe cheap ketchup consistency to help fill any cracks or voids and any imperfections that would be between the fabric and the core on this side. We radius the top, as I pointed out earlier. Now that the core is in place, we're going to put a little fillet on the bottom. Again, fabrics don't like to go around 90-degree corners, and this will help out. One of the other things we could have done was taken the time to cut a 45 on the edge of the core. Though with balsa being in chunks, that's kind of difficult, but if you're doing plywood or a sheet of foam, it works out pretty well. Or if you can get a pre-made 45 for the corner, also works well. So a couple of things to take in consideration when doing a large vacuum bagging project. One is the amount of time it takes to actually do the entire layup. As you see now, we're over an hour into this, and we still got 3 more layers to go, but we're using a slow hardener, and it's about 72 in here. If it was hotter out, you would want to go 209 or a larger project. And I also got help from Don on wetting the core out, mixing my batches. As you can see, even mixing up a small batch takes quite a bit of time. If the epoxy starts to cure, you're going to lose your benefit of the compression of the vacuum bag. So you want to make sure you get done within the working time of the hardener you're using at the temperature we're working at. As we start doing the fabric over top of the core, we're getting more and more complex corners. And it makes it difficult for laying in fabric because as you pull here, you pull it away from there, you pull it back, it pulls this way. So it does take more time and consideration to go into place. But it's worth taking your time. Again, the vacuum bag is not going to make up a lot of differences. If it's bridged, the vacuum bag will not pull it into a corner. So you want to do a good hand layup, and the vacuum bag is just a little extra. So when working with carbon, unlike fiberglass, when fiberglass is wet out with epoxy, it becomes translucent and loses its whiteness to it. So you can really tell when it's wet out. With carbon, it's hard to tell if you've got some epoxy on there, if it's completely dry, or if it's just kind of finally getting saturated. So it's good to have good lighting when working with carbon to make sure you don't miss any spots and that you get plenty of epoxy on there. So even though that area looks dry, when you press your thumb down into it, you can see the resin coming out from around my thumb, and that you know that that's wet out well, even though it's looking dry. It's the best way to tell if with carbon. And because this is the last layer, I'm going to work off some of the excess resin. I'm not worried about it soaking into the next one. Now that we've got all of our layers on, we're going to go around and clean up the edge and get all the strands that come across the tape up and get nice and neat to put down our vacuum bag tape. Any strands that are left out, the vacuum bag tape goes across, will create a leak in the bag, and ideally we don't want any leaks. Now that we're putting on the release fabric, this acts as a release barrier between the epoxy and the consumables that go on top of this. We'll add perf film next. One thing with putting on release fabric is it does not stretch at all. So you have to kind of be very gentle, and you don't want to create any bridging because the vacuum bag will not pull it down. So you gotta make sure it's tucked into the corner as well. This is perf film. The purpose of this is to help balance the resin content and let the excess resin come out. There's pinholes in here, and if you can either purchase it this way or you can make some up out of some plastic film and a needle. It just takes a little bit of time, but it works out as well. Now putting down the perf film, you want it nice and neat, and again, tucked into the corners because it does not stretch, so you want to make sure there's no bridging, which is where the plastic spans from the top down to, say, the middle and creates an air void underneath. Again, a wrinkle is better than a bridge on this stuff, so if it's not perfectly neat, that's better than not being tucked into a corner. The next layer going down is the breather fabric. And breather fabric serves a couple of different purposes. The main one is doing exactly what it sounds like, breathing fabric. It allows the air to flow underneath the bag equally in all areas. The second purpose of it is the resin that comes through that perf film will be soaked up by the breather fabric. And with this one, I'm putting down 3 layers. This is a thinner breather of material. It's better to have extra because if the resin doesn't soak up into it, it can be reused. But you don't want to saturate the baby blanket because if you saturate an area, you lose vacuum in that section of the part. So the only thing that we're missing now is the vacuum bag sealant tape to seal the bag to the mold, and we'll put that on next. What we want to do is be very careful as we remove the tape to make sure that we keep the area nice and clean. If you get any epoxy on there or strands coming across, you got to make sure to clean it up with a solvent so that the vacuum sealant tape will actually seal to the mold. At this point, you can remove your gloves. Working with the sealant tape, it makes it a lot easier, and you shouldn't be getting into any epoxy because you had the tape down that you removed and working on a nice clean area of the mold. The next layer going on is the vacuum bag. You want it to be much larger than the part itself because you need to go up and down through all the contours, and it's better to have a big wrinkle in it again versus having that bridge across someplace. We'll show how to put a pleat in to show you how to get extra room in the bag over the part area. So as I know the bag's much bigger than the part, we'll start in the far corner and we'll leave it with some overlap. And then as we remove the backing tape, we're only going to remove the area that we need to use. We don't want to pull it off all the way around and take a chance of it getting dirty or the bag getting stuck to it in the wrong positioning. This area here where the flange comes out, we know that there's a change coming down and back up. So that's a place we're going to want to have some extra bag. So we're going to put a pleat in so that we have extra bag in that area. Put a little tacky tape, glue them together, and then just work up your bag a little ways. And then fold your bag over, put a little fold at the top, and come down and seal the bag to the other side of the tape. And this way it's sealed on both sides, nicely in the top, all the way to the bottom it's connected. So we'll put one here, and then when we get to the other side, we'll put opposite. That way the bag stays square to the part. And as you work along, you want to make sure that you keep your bag nice and clean. If it touches inside and gets a little epoxy on it, it's not going to stick to the tacky tape. Again, down on this end, we know we have another trough, so that we're going to add another pleat in. Now that we make our corner, we know we have another trough here for the other side of the flange. We'll make another pleat on this corner. Come around a little bit, get lined up. And as you work your way around and making these pleats, you also want to kind of pay attention to the rest of the bag. Once again, you don't want to get it dirty, but you also want to make sure that you're keeping it square. Again, we have a pleat on that side of the part, so we're going to put a pleat over here. Make sure we have enough bag. Now we're going to attach the vacuum to the part and suck the air out of the bag. We're going to use a little suction cup to attach it in a hole in the bag. Ideally, we'd go onto the flange, but this particular flange is not wide enough for it. If you put it just general in the part, it will leave a mark where it's being pressed in at. So what I'm going to do is try to locate it over top of the wood block, because we know we're going to cut that section out anyways for the latch handles. I put a little black circle where I'm going to mark my, cut my little hole in. That way where I know the location of it. So that when I go to put the cup on there, I don't miss it, and they'll be able to find it later if it pops off. As the vacuum draws down, it's good to tuck the bag into the corners to make sure you don't get any bridging. So now that we've got the vacuum on here, on the vacuum pump, we've got it dialed to about 12 inches of mercury, which is about 6 foot-pounds of pressure per square inch. To know that we've got equal pressure across the whole bag, we put our vacuum gauge on the part. We generally put the vacuum gauge opposite wherever we have our vacuum coming in at. So I'm going to come over here to the wood block on this end and center it on that, so that again we don't make a dimple in the part that we're not going to get rid of. Again, a nice flat area with no wrinkles in the bag, and circle where it comes off in case someone knocks it off or something happens. You can relocate your mark. And we see that we're getting 12 inches of mercury on this end of the part also. So we know we're in good shape, and likely there's no leaks. So we left the vacuum on overnight. You can see it's still pulling down good, 12 inches of mercury. We'll shut it off now and begin the debagging process. You can see where the epoxy came through the perf film and soaked into the breather fabric and created all these little dimples. So it did its job. There's no areas where it actually sealed off the vacuum, so that's a good sign that we had about the right resin content to begin with. The bag, the breather film, peel ply, and perf film are all consumables, which means once we use them, we throw them away and we're done with them. The release fabric is the hardest part to get started and pull off because it's embedded into the epoxy. So it does take a little effort. I like to cut it into strips so you're not trying to pull off one large sheet, and you do it in sections is a lot easier. Also, a lot of times on a large flat part like this, using a rubber mallet, just kind of beat on the bottom of it, helps vibrate it loose a little bit. Find a spot we can start getting a wedge under and work them in. You can cut wood wedges. I use our mixing sticks with a little wedge here to start with. Sometimes I'll use a wood chisel so I can get a little prying on it too when needed. But you can see where the white pigment will help cover up when you go to put primer on it. It's just a little extra rather than trying to cover over the black. And you can see this little rough area here where I didn't have the fillet put in real smooth, and it created a little bit of a crease there. We go back to the beginning, the frame that went around the side, the height of it I calculated in so that the top of it ends up being this flange sticking out, so that when we cut it off, it'll be the right height. Many ways of doing that. You can just simply take a jigsaw and carefully cut along the side here, a bandsaw. You can sand it off. We're going to use a router. The bearing with the top bearing, which will ride along the edge of the hatch and cut the flange off straight. And then we can go back later and clean up with the sander and make sure there's no sharp edges. And of course, when you're cutting and sanding, you should always wear protective gear. A lot of mess here. What I like to do is I tape the sleeve so that none of the dust blows up my sleeve. You want gloves, hearing protection because we're using a loud tool, and of course a good quality dust mask or respirator. It was expected that this flange, obviously with carbon, is a little bit jagged and kind of sharp, so we're just going to take a palm sander and just hit a little bit and round off the edges a bit. Could do it by hand with a long board to keep it straight also. Number of different ways of sanding it out. Using electric tools with carbon is not always the best choice because the dust gets into the components and shortens the life up considerably. So it's not something you want to do long term. Now that we've trimmed the hatch up, it's time to install the hardware. We're going with latches this time versus just a lifting ring. We'll be drilling a 2-inch hole for the installation of this, and then we'll seal it with epoxy. So when we fabricated this hatch, we installed a piece of plywood in the area that we knew that the latch would be going into. We're going to be drilling the hole in the center of the hatch and then 4.5 inches, which will make a good area for this to be on the other side. So drilling through from just one side, pushing through, a lot of times you'll get tear out. Like in wood grain, you get the same effect in carbon fiber or fiberglass where it destroys the surface. So I only drilled part way through, making sure the center hole went through. We'll flip it over and then we'll drill back the other way so we'll have a nice clean finish. So we found our centering hole and we'll finish off from the side. Now that we have the hole drilled through, we're going to sand the inside a little bit just to clean it up. We're going to coat this out with epoxy. We're going to do 2 coats, waiting for the first one to get tacky before applying the second one. This will give a good moisture seal on the wood. Also, when we installed the block, it was coated in epoxy, so if this was to fail, the moisture wouldn't be able to travel outside that block and you'd only have a small repair because all the balsa is sealed off from the wood and each block of balsa is sealed off. Now that we have the wood sealed with 2 coats of WEST System Epoxy and it's been cured, we're going to do a last dry fit. Just simply putting everything in place, checking the length of the fasteners. And you just want to make sure that you have enough room on your fasteners. It goes through the backing plate and you have room for washers and the nuts on back. Now that we've done our final dry fit, know that there's no more modifications that need to be done. We can do our final finish of sanding and painting, install the latches with some sealant, and it'll be ready to be installed on the boat. Overall, we end up saving about 20 pounds of weight with a much flatter and stiffer hatch. So I think the project was a big success.